when we wind up with a straight line for a graph, one of the things that we ordinarily want to do is to find its slope. And this is something that all of you have been doing in math class, probably in Algebra 2. Maybe you've done it in a previous science class as well. So to review that, how do you find slope? Remember what the formula is for slope, or how you learned that? Rise over run is one way you learned it. Yeah, or what was the other thing you started to say? Changing y over changing x, because y is the rise and x is the run. Yeah, so either one of those, delta y over delta x or rise over run. That's the general procedure for finding the slope. So on a graph, if I have a graph of y versus x, and this is my straight line, the rise or the change in y would be how far it moves vertically between 2 points, and the run or the change in x is simply how far it moves horizontally between those same 2 points. A couple questions though. When you're looking for those 2 points to get your slope, should you pick 2 actual data points off your data table and use that to get the slope? Or is it better to use 2 locations that are on your best fit line? Yeah, it looks like we're not quite sure about this one. The majority of you do have it. You want to use locations on your best fit line. You never want to use data points to get your slope. And I want you to understand why. If you look at my sketch here on the board, those green things are supposed to be my data points. What if I were to use just these first 2 data points to calculate the slope? What would I actually be getting the slope of if I use those first 2 data points to calculate the slope? You'd be getting the slope of the line that connects those 2 points. And if I connect those 2 points with a straight line, is the slope of that thing anywhere near the slope of my best fit line? No, I could be way off. And the same's true with probably any 2 data points in that line. Bottom line is this: the only way you would ever use data points, the only way you can get away with that, is if what were true about the data points that you chose. If the data points just so happen to lie on the best fit line, then it'd be okay to use them, but ordinarily that doesn't happen. So ordinarily what you're going to do is just find 2 locations on the line to get the slope. All right, second thing, when you're looking for points to find the slope, is it better to pick 2 points in the line that are close together or 2 points that are far apart? About half of you think that the points should be further apart, about half of them think they should be closer together. And let me make sure you understand the question. Here's what I'm saying. This time for this red line, if I'm trying to find the slope, what I'm saying is, should you pick locations like here and here to get the slope, or should you pick locations here and here to get the slope? And about half of you said the one, half of you said the other. Well, understand that either way, you're going to have to measure delta y and delta x. In one case, your delta y and your delta x are going to be teeny tiny. In the other case, they're going to be a lot larger. Agreed? Now, either way, there's going to be some error on your part in trying to figure out how big delta x and delta y are. You're going to be a little bit off. Now, is it a bigger deal if you're a little bit off on a measurement that's really big or a measurement that's really small? Now, if you're measuring something that's only 3 millimeters to begin with, and you're off by 1 millimeter, right? That's a pretty big deal, isn't it? You're off by 33%, 1/3. But what if you're measuring a distance that's 100 miles long and you're off by 1 millimeter? Who cares, right? I mean, it's such a small percentage of the whole thing that it doesn't really matter. They should be far apart. The further apart they are, the better, because the further apart they are, the less any error that you make is going to influence the result. All right, so the next thing we want to do is to actually calculate the slope. I want you to actually try this. And let me take you through how to do it. And I'm actually going to go back to this slide right here where we had the graph. What I would do is I would find 2 points on my graph where my line of best fit actually intersects 2 of my grid lines, because it's a lot easier to get the coordinates off of it if you find places where it intersects the grid lines. So for example, if I look at the graph down here at 80 milliliters on the x-axis, you see how there's a grid line there at 80 milliliters that runs right through the line? And then I would come over on the y-axis, on the mass axis, and try to estimate what that value is. And it looks like it's about 80 grams going along with 80 milliliters. And I would actually label those coordinates on the graph. In fact, let me sketch this over here so I have a record of it. This is mass. Flip views here again. This is mass in grams, and this is volume in milliliters. And my lines look something like that. And the point that I was looking at right here had coordinates 80 milliliters, 80 grams. Right? The x coordinate was 80, and the y coordinate was 80. And then I look for another location on the graph. I thought I had switched to that, but I guess I didn't. 80 milliliters, 80 grams. Then I look for another point in the graph somewhere at the other end of the line, hopefully again where it intersects some grid lines. So if I look at my graph, notice the 20 milliliter line over here, that runs right through my line. And if I come up from 20 milliliters and come over, it looks like that's roughly 20 grams. Right, so I label the coordinates for my other point. Right, this other point was the point 20 milliliters, 20 grams. And then from there I go to calculate my slope. And I know slope is always rise over run, or delta y over delta x. And I'm not dealing with y's and x's here, I'm dealing with masses and volumes. So I'm going to write this as change in mass over change in volume. That's really what I'm doing. And now I'm going to write down my steps here so I can go back later and see my work. My change in mass, I went from 20 grams to 80 grams. So I'm going to have 80 minus 20. And the same thing for the volume in this case. 80 minus 20. And then finally, do the math and express my answer as a decimal. All right, take a few minutes to work yours out and see what you get. You should be getting something close to 1. And how many of you are getting something close to 1 for your slope? Maybe a little above, maybe a little below. And again, with 19 different people, we're going to have 19 different lines of best fit. So that's going to account for some small differences. Let's say you do get 1 for your slope. How do you record that answer? Look at the choices up here. Are all these choices appropriate? Are they all correct ways of expressing that slope is equal to 1? I'm guessing a math teacher might be happy with any of those, but I would not be. Yeah, it looks like the majority of you like the one that I like, which is choice 4. Right, choice 4 is the correct answer. What's wrong with 1 and 2? I mean, the problem is fairly obvious, right, Kelly? There's no units, right? 1 what? And again, a math teacher might be okay with that because we're just dealing with these arbitrary y's and x's are just numbers. But in science, it has some meaning, right? The y was the unit of grams. The x value was the unit of milliliters. So when you go to do the slope, if you look at your work, it's so many grams divided by so many milliliters. So make sure you have units, right? Check what you've written down. Do you have units following the number? You know, if you don't, on a lab, yeah, you'd lose some points, right? Because it's meaningless without the units. So you got to get in the habit of including units with any measurement that you write down, or any calculated value, like this one. So 3 and 4 both have units. What's wrong with 3? Yeah, with choice 3, you're saying that 1 is an estimated figure. In other words, there's only one significant figure there. You know, maybe it's 0, maybe it's 2. We can do better than that, because if you look back at your data, every last piece of data that I gave you was to the nearest 10th place. Right, if you look at your data points, you have things like 20.0, right, 80.0. So if your data was given to the nearest 10th place, right, when you go to do the subtraction, right, good review here of what to do with addition and subtraction. The rule for subtraction says you always include the same number of decimal places as the smallest one. So these are both to 1 decimal place, therefore when you do the subtraction, that has to be to 1 decimal place. So 60.0 grams. And the same thing with the volumes. They were all given to the nearest 10th place, 1 decimal place. So when you do the subtraction there, you're going to be to the nearest 10th place. Right? So that was subtraction, but now we have division to do. And for division, we don't look at decimal places, we look at significant figures. How many significant figures in 60.0? 3. Yeah, there's 3 significant figures. 60 milliliters also has 3. Therefore, your answer has to get rounded off to 3 significant figures. So if you just write 1, that only has 1 significant figure. To make it 3, you have to make it 0.00. Right, and then include the units. So 1.00 grams per milliliter. That's the correct way of recording that slope. So look at what you've written down. All right, number 1, do you have units? Number 2, do you have 3 significant figures? All right, if you don't, fix it up and make it right. Now, what did LoggerPro end up with? Now, computer is going to do the best fit line. When LoggerPro calculated it, it wound up with 0.997 for the slope. And notice LoggerPro knows to include units. It says 0.997 grams per milliliter. Right, so it does it correctly. So actually, the best fit line you could draw has a slope slightly less than 1. Does anybody get 0.997 for theirs? It'd be really strange if you did. It's very close to 1. Slope has units. Watch significant figures. And one final thing that I want to mention that's not part of that PowerPoint. Why in the world would I have you do this? What's the significance of finding the slope of this graph? Is it just because, gee, they taught you how to do this in Algebra 2 class, we might as well practice it? Or is this number telling me something? What have I just calculated for this liquid? Right, Dylan?
Density.
I calculated the density. How do you know that?
Because it's all mass over volume.
It's mass over volume. And you remember from somewhere, maybe chemistry or 9th grade science, that that's what density is. Density is the ratio of mass to volume. And that's what we did when we took the slope. We took the change in mass over the change in volume. So really what I did is I calculated the density of this liquid. And by the way, if it has a density of 1 gram per milliliter, most likely this is what liquid? Yeah, this is water. Right? Water has a density of 1 gram per milliliter. Now somebody might say, okay, I see that that's what it's giving me, but why do it that way? Why not just take mass and directly divide it by volume? I mean, I gave you a data table yesterday with a whole bunch of volumes and a whole bunch of masses. And correct me if I'm wrong, but I think the very first volume in that table was 10 milliliters, and the very first mass that went with it was 12 grams. Does that look right? So why not just take that mass, 12 grams, and divide it by that volume, 10 milliliters? I mean, that's what the equation says to do, right? Why is finding the slope of the best fit line better? You got it averages out the errors. I mean, you can look, if I just used this one data point, I would have gotten a density of 1.2, which is quite a bit off from what I got from the slope. The slope is 1.00. So when you look at your best fit line, some of your points are above the line, some of the points are below the line, but when you draw that best fit line, that averages out all that data. That's why it's a better technique. And that's why almost for everything in this course in the lab that we're trying to calculate, that's the approach we're going to take. We're going to collect a whole bunch of data, we're going to plot it, we're going to get a straight line and get the slope of it. The slope gives us a better value. Averages everything out.